All right, we are live. Hello, everybody. Thanks again for joining. If you're tuning in virtually and watching the stream, this is our weekly get together of various folks on the Epiphyte team where we talk through the design of our open source direct air capture prototype. Um, and what's exciting about right now, as we've been kind of threatening for the last couple of weeks, is that we have the money to buy our materials in the bank account. And so we're getting to a point really right now, today, tomorrow, and over the week, where we're going to order the parts that we're confirmed on. So we're going to have a little bit of a conversation. And this next build, for those of you who are new, is going to be at the University of Texas at Austin, where I am located. And we have an amazing team at the UT. Oh, great. Here's Will. Speaking of UT people, they will. Just giving a little preface to the session. So we're going to be building that with an amazing group of undergrads and graduate students that are part of the Negative Emissions Technology or NET Club. And there's quite a few people that have joined. And so what we wanted to get down to today was to make some final determinations so I can order the parts that we're confirmed on. And we're hoping in the next really week or two, we're going to start actually putting this thing together. There's still a lot of things to figure out, but some of those things we're going to sort of jump into the unknown and figure them out once the parts arrive. So how's everybody doing? Will, how you doing, man? How was your week?
Doing good, doing good.
Good. We saw a bit of a whiff on the on the monolith supplier we were looking for.
Yeah.
But again, maybe we just go the Alibaba route. So we'll just talk about that first. A key component of the Epiphyte is the device or the product that holds the sorbent. And this is not really the most representative example, but that's called a monolith. And they're these round objects made out of ceramic, either cordierite or alumina, that through a wash coating and heating process, we basically embed the sorbent that we're going to use in there. And these are ideal because there's a lot of surface area that can be filled with sorbent, but they also have, air flow through. They have these little cells. Ours will have a lot more cells than what you see pictured here. So it allows the air and the heat to flow through that object. And so we've been trying to, you can get these from a lot of different places. We went down a bit of a dead end with one supplier in Southern California. It doesn't look like they have what we need. We know that these are available on Alibaba and other suppliers, but we kind of want to be able to talk to a supplier that we feel like we can kind of communicate with regularly as we sort of, try to optimize for which product we want. Will, I did reach out to Corning this morning. I submitted a quote request, product request for them. Corning, the major materials, company, they are the ones who provided the monoliths for Kirsch's team at Clarity Tech.
Okay.
So we know that they have them. We'll just see if they're within the price range we want. But I did submit there, and hopefully that provides at least one option. But what I'm going to say is we just order all these other parts that we can right now just to kind of do the mechanical assembly. We know that the diameter of the other parts will allow us to drop in the monolith once we get them. So that's my suggestion. We have a new attendee as well, Evan. Evan, awesome to have you. He's in Chico, California, a chemical engineer, and he jumped onto our Discord and said he wanted to join. So, Evan, you can stop us and ask any questions you have as we go, and just be sort of a fly on the wall if you want to, or be as involved as you want. But always great to have another Chemi join the team.
Perfect. Yeah, thank you.
All right, cool. So we had a great meeting. Me and Tom and Chaz and a couple other members of the NET team met in person at UT on Sunday. That was a pretty great conversation, I thought. I thought we covered some things in some detail. Charles and Thomas, do you guys have any sort of additional thoughts post that meeting on what was discussed?
No, I agree that it was a good meeting. We talked about a bunch of good stuff and the motion we're going to. The more I think about the calibration machine, the more I really want to do it. That's my big thing.
You want to
Um,
just quickly explain that? I quickly get lost because I'm not a scientist or an engineer, but in concept sounded like a good idea. But yeah, you wanna
basically,
just explain that piece.
basically, some of the sensors that I want to make sure we included, given that it's an open source and also for like optimization of running the machine, specifically sensors on the intake and outtake of flow lines of the like DAC machine
Hmm.
are if you want to have them in there always, like install them into the actual machine, it's a trade-off of accuracy to like disruption of flow kind of thing. Because like it's gonna be more accurate if it's near the center of the pipe, but then we have to get it somehow there, and it's gonna disrupt the flow on the way out, as well as like the heat problem and all these other problems we were thinking about that have to do with that. That it feels like a better option would be to have a detachable part or attachable part um, that we could attach to the machine, have those sensors there, disrupt the airflow for a time while we're still trying to figure out how to optimize fan speed, temperature swing, all that stuff, and then be able to detach it for like long standing running, if that makes sense.
Okay, well, I'll follow your lead on that. I can't remember. Does that imply that we need 3 sensors? I can't remember, or 2.
So that would mean that we need, for in terms of like the high efficiency ones that you have, or that you gave us rather,
Yeah.
we need one of those for inside the deck machine, one of those for inside the sequestration chamber, and then I think one more for the one more for somewhere. I'm drawing a blank on it. But then the less like efficient sensors, or like are the ones that we have already, um, those ones can be used for that calibration idea that I'm coming up with.
Okay,
Yeah.
great. And just to also, Evan, I don't know if Evan, have you ever watched any of these videos before, either post recording or live?
Yeah, I checked out last week's meeting actually.
Okay.
So yeah.
So you're familiar with the general design that we're pursuing here, but I'll just show an image. And we have a kind of a question about whether it's going to look like this or this, which involves some math that I think some folks on the net team are looking at. But let's just use this just to sort of lay it out. We're going to put our monoliths inside this pipe, which we actually source from a stove and chimney supply company, which is a great thing to hack off of because they're optimized for airflow and high heat, which is what we need. Damper on top, damper on the bottom. We're going to have a heater, which I'll show in a second. I think we might just want to go ahead and jump into the dark and order the one that we're looking at. The one difference that this has, actually, I'll show you Ling's picture, which I think is more representative, is putting a fan below the heater that can do one or two things. And this is what we're trying to figure out with this math problem: is how fast and strong does the air moving through the monolith have to be for the purposes of absorption, right? So my thought might be that we went a little overkill last time, where we had this really big fan that's like, it really pushes a lot of air through. But we might be able to get away with a smaller fan that can also do double duty as a air circulator during the desorption phase when the dampers are closed, and we want to make sure we maximize the airflow through the monoliths when it's heating. So that's the basic thing, design that we're going for. There's other parts too, which we did talk a little bit about on Sunday, is that we want to do something with this CO2 pretty much right out of the gate and include that in the design. And that is this idea of taking wollastonite or potentially brucite, ultramafic rock powder, and mineralizing it by injecting the CO2 into a chamber with that material and in solution, and applying some heat and a little bit of a vacuum to accelerate the reaction time. So it's useful to us, Evan. Is the first time we're chatting with you? I'm curious if you have any general questions about our approach here, or even some ideas based on what you know so far.
Yeah, so I'll have to think about it for a bit. But
Yeah, no problem.
It
But
does seem like an interesting an option for mineralization here.
Yeah. Yeah, we think it'll be good. There's kind of cost considerations and supply considerations, but Wollastonite is like the as I say, the sort of Usain Bolt of ultramafics. It's like the fastest reaction, but sometimes it can be a little more expensive. And at scale, it's a much more precious material compared to brucite, which is more common. But we can always do either or, doesn't matter. But we have the sequestration team at UT is already thinking about that, which is exciting, and that'll be, I'm sure, discussed at Thursday meetings on Sundays when that group meets up. And what I wanted to do again is just sort of get confirmation on the parts we're going to order. Before we do that, Will, I didn't know if anything interesting happened in the lab this week regarding testing and stuff like that.
Yeah, so far on my end, I think what's happening is, whoops, sorry. I think that the monoliths I'm using from here in lab just might be contaminated, or in general, I think we have to prepare the surface in some way. I was looking more into literature, and all the stuff that people do, at least like in lab settings, it's always with like powdered alumina. So I don't really understand why powdered alumina can just more easily grab PEI, it seems, because no one has been doing any like pre-treatments with powder. It's just like mixing the PEI in a solvent, then throw in your alumina powder, and then it's grafted onto there. And that's what I saw too for my preliminary results with the powder alumina I had in lab. Once you go to a solid alumina, like monolith, like a block of alumina, it doesn't work as well. And I think just like the surface, there might already be something on the surface that the manufacturers put on afterwards, like once they produce it. I'm not really too sure. It's supposed to be just pure alumina. So what I'm trying now is just taking the old aluminum blocks that I had, and I'm wash coating it. Sorry, not wash coating it, but I'm chemically treating it with a potassium hydroxide bath to try and etch off any chemicals that are already on there and maybe expose the surface better. And I'm also going to just try physical abrasion. So just like taking like steel wool and just like grinding the surface and trying to clean it that way, polishing it off. Another thing too that I was seeing that kind of what Kirsch does is they do like a pre-coat. So kind of like when you're painting a car, you have to put a primer on first. So you like clean the surface, put the primer on, then you put the paint on, and the paint goes onto the primer technically, and that's like the middleman. I think we're gonna have to probably do something similar for our monolith as well, and it's probably gonna be like a silica gel that goes on top of the monolith, and then after that you put the PI on. But I think even with the silica gel pre-coating, we probably have to prepare the surface anyway. So like either abrasion, scraping it off, like steel wool polishing it, or maybe like KOH bath, or maybe both. It's not really too clear what's the best way to do it.
Okay, that sounds good. Evan, I know you're a sorbent guy. I am just going to throw in the comments here. This is the sorbent that we're going to start with. Over time, we want to be able to experiment with all kinds of sorbents, even things that we develop. Will's a big MOF enthusiast, and he's been working on synthesizing MOFs and stuff. So the overall form of this will allow for various, but we figured we go with something very known that we know will work, that was recommended to us. So I popped in the comments there, just the product on Sigma Aldrich, which we'll hopefully order today. But didn't know if you had any. Feel free to weigh in at any point, Evan, if you have any thoughts on sort of this particular sorbent or other ones we might want to look at. It's been quite a process trying to land on one that we think will work better than what we used last time, which was a zeolite.
Okay, yeah, I'm a big MOF enthusiast as well, so interested to see the future direction for sorbents. Are you using liquid sorbents right now, or?
Oh yeah, maybe I should clarify. So the thing we're doing right now is technically not a MOF. It's PEI, so it's polyethylene imine. So it's just a branch chained carbon, an alkylamine carbon. And if you look on that link for Sigma Aldrich, it'll give you kind of like the structure of it. But it's a solid state, yeah. So we're not using liquid amines, kind of like what they do in like flue gas scrubbing or whatever. It's all solid state, and we're trying to graft that chemical onto a monolith, like catalytic converter, honeycomb looking thing. And that's kind of what the step we're on, and it's proving to be a little bit more challenging because I think it's going to take a bit more work than just simply dipping it into a solution of PEI and getting it on like that.
Mm-hmm. Yeah, and I think what we'll do, Will, is we did get a response from Kirsch from Ling's question, which was helpful. And he's a great guy, super busy, obviously. But I think what we're going to want to do is almost like a cooking class and how he does it. And when we have MOF in hand, I'm going to invite him back on, whether it's on this, Wednesday session or we schedule it, whatever works with his schedule. Let's just have him walk us through exactly how he does it. I think would be good.
Yeah.
One other thing he does too, which I know is we'll order a couple extra monoliths. And when he's testing, he has like a coring device, which I think I described, almost like an apple coring thing, where he pushes it into the ceramic and just pulls out a little core of a monolith. So like a little mini monolith kind of from a monolith.
Okay.
And they do the testing with that. So we'll just order a couple extra monoliths that you can use for testing purposes. So you have the cell structure and all that stuff, but you can just kind of get like a little piece out. All right. Whenever the hell we get the monolith, which I'm sure we'll be able to find one. All right, cool. Any other questions, Evan?
Yeah, so you said you're looking at developing maybe your own MOFs in the future. Are you also looking at maybe just buying from suppliers, or is that?
Yeah, we've looked. There's usually fewer, at least cost, non-cost prohibitive MOFs that we could use for this. We did a while ago look up a couple, a supplier that I think is in Switzerland and stuff like that. But I don't know if you have any recommendations for off-the-shelf MOFs that would work with this sort of model that we're making, with a monolith. We're open to any suggestions you might have, as long as it doesn't cost $1 million. Or even
Yeah. Not at the moment, but I do know of some groups that have been looking into like functionalizing MOFs with the means. Have you thought about that?
Will, you're the MOF man. The MOF.
Yeah, we looked at one that's made. His name is Omar Farah in North University. Wait, what's it called? It's the one in Chicago. Northwestern. There we go. Yeah, they made a really nice MOF over there, and they basically did the same thing where they use magnesium oxide clusters, metal cluster nodes, and then they attached onto their small alkylamines. So that was originally our first plan for last semester with the DAC team, but we ran into like a serious issue with like cost of stuff because the chemicals they use is pretty expensive to make MOFs. That's usually like the general trend with MOFs, is that they're pretty pricey. Yeah. And then Chris came along and he's like, we got a bunch of money, so then we started looking at PI because it's just a little bit cheaper and we can buy a bunch of it, and it's probably a little bit easier to work with too. The MOF synthesis can be pretty like picky, so you have to be very like delicate with it. And I tried doing it twice and it didn't come out right. So I already knew it was gonna be a challenge, but PI is just like already made and we're just trying to get it onto the surface. It's a little bit easier. But I do think MOFs are the future though. I do think like overall that'd be the general trend we want to go to, but make it like a user-friendly MOF, which I think is probably the biggest challenge.
Yeah. They have stability issues and a whole lot of issues, but hopefully it gets something can get worked out here.
Yeah, we look forward to your thoughts on that, Evan. Will also is just wrapping up his PhD in chemistry at UT, so he's pretty advanced in his experience and knowledge. And you were first introduced to me, Will, because you were working on MOFs. That was why. So you guys will have a lot to talk about. Will, you're Penguin something, the Penguin guy. You'll see on the Discord, Evan, if you want to DM him.
Okay.
Geek out on MOFs. All right, cool. Let's go ahead and just, I'm dying to, have some retail therapy here and buy some stuff. So I'm going to open up the document that is evolving into our bomb. Let me share my screen here. And let me know when you guys can see it. Can you guys see it?
Yep.
All right, cool. Sure. All right, so let's go up to the stuff that I think we're closest on, or in fact, probably ready to go on. And those would be our dampers and our pipe, our tube. Okay. So I like the dampers, I think kind of a no-brainer. But I think with the diameter we want to go with is if we did a 7-inch interior diameter for our, both for the pipe and for the damper. These are both from the same supplier, so they're meant to fit together. That is good because then we could plop a 6-inch diameter monolith in there with a little bit of wiggle room around it for both airflow and also so it's easy to take in and take out. If we do a 24-inch long one and we have 6-inch monoliths, that allows us to actually put in, a good number to get a few in there. And it's pretty cost effective. When I looked at it, I think I can get that for like $150 or something like that. So anybody have any objections for me pulling the trigger on these pieces at this point? Are we good to go?
Go for it.
Yep.
All right. I love it. I wish Ling was on. She's always our reasonable voice of caution. All right. So now that's bright green. That means I'm ordering it today.
We'll just enable you. It's fine.
What's that?
We'll just enable you. Don't worry.
Yeah, do it. Exactly. Enable me. So with the heating thing, this is a really important part. And the things that we want to have here is we have to get pretty high heat, right? And so a lot of the heaters we looked at before that are for HVAC and stuff like that, or for, other purposes, don't get us. I think we want to at least be able to get it up to 120 potentially for PI. It's somewhere between 100 and 120 C. And what we like about this product is it's can be easily moved up and down. We can work with an Arduino. It's small. Air can flow through it. And it can get all the way up to 316 C. And it's not horrible in terms of pricing for a specialty item. And so I'm going to open it up. Let me know if you guys can see this. Can you see this?
Did you open up something new, or is the same?
Let me do this. Let me just share my general screen here. Present, share screen, do entire screen. Boom. Okay. So I'm going to this. Okay. So this is the unit, and this is the data sheet right here, just to show you a little bit more. Is it does have this coil, the heating coil there, but air flows through it as it's meant to. This is a little 4-inch flange on the bottom, and they come in different sizes, where the smallest length one is 6 inches, and the longest one is, I think, 12 inches or 166. No, that's not it. 12 inches. So anywhere between, actually, the ones that we want are between 10 and 12. So I'm scared to make a final determination on this. I have not been able to get in touch directly with the supplier. So maybe what we could do is one of us could actually call. There is an 800 number on the bottom, and just to ask some more specific questions about modifying the heat, basic questions about, warranties and stuff like that. But I think we're close on that. Does anybody, let's say this was perfect in terms of functionality. Do we have any reasons not to choose this based on the overall design?
I don't think so.
All right.
I used to be a contention for it, but now that I know that it has airflow through it, I got nothing.
Yeah, so that would be good because the fan goes below it. But I think we should call. I didn't know if, with just a couple of prepared questions, is there anybody on your team, Chaz or Tommy, who might want to put in 20 minutes to give these guys a call?
Sorry, I didn't realize my mic was muted.
Basically, we want to call up the supplier here and Omega and just tell them what we're trying to use it for, and have them not talk us out of using it, or answer some questions. I think it would be good to, how long does it take to get? How good is the airflow? Is there any obstruction from that coil?
Sure.
I am interested in these connectors here, about how we, we're going to integrate this. So you guys are the engineers, but I think it probably would be a good call to just call them up and say, hey, we intended to use it for this purpose. And if they have any kind of questions or ideas, but if they give us a positive indication, then I'll go ahead and turn that bright green and order it as well.
Okay. Yeah, I can get the mass transfer in that team on that for sure. And that link that you have there, that leads to the number?
Yeah, so you can click to, there's both the spec sheet and the general product page. The spec sheet you can find on the data sheet on the one page, but you can easily get to a 1-800 number. And then, we can add this to the GitHub. I was hoping Ling would be on here because I need her to help me with something on that. But I can just send it to you by WhatsApp or on the Discord of the kinds of questions you want to ask. But
sure,
I think just we're one call away, and from confirming that and then ordering it.
Sounds good.
Okay, cool. Now the other big piece we want to make a determination on is the fan, right? And so a couple of weeks ago, the big thing we need to do with this is to find out. Oh, let me just pause on that for a second. Tom and Chaz, do you guys have what you need to do that math problem to find out how much airflow we need for this to be useful for adsorption?
It's kind of, I mean, like, so, uh, Will, do you have, like, you're gonna be able to give us estimates on that in terms of, like, how much heat and its capacity at a certain temperature, right? Like at ambient air?
Hmm. For the so do you want the heat first, or do you want the airflow? Because for the heat, it's a little bit simpler. I think it's going to be
Yeah,
dependent.
airflow is the big question, because if we determine that with one or two of these fans, we might put just one on the bottom, but also one on top, depending on how much air is required.
Hmm.
That if we feel like this is enough airflow for adsorption, then we can eliminate that second fan as well as that other joining T-piece, and that'll reduce our costs and just make for a simpler design.
Yeah,
We want the answer to be yes on that. So it's really more about phase one adsorption.
yeah, and I really do think even if you have like a slow airflow, because there is probably gonna be like a pressure drop or like resistance to the flow because of the monolith and all that.
Yeah.
But even if that's the case, I think even just having one fan and just letting it go longer would be the solution. It may not be as efficient, but I think because eventually you'll get a saturation. That's the main thing, is that at some point the sorbent will get fully saturated. So even if you're using one fan or three fans or whatever, you'll get to that point eventually, but it may just take longer or shorter depending on your fan power. In terms of some numbers, it's kind of hard to say. I feel like this fan, 450 cubic feet per minute. I think that's what the unit is, CFM. That sounds pretty beefy, actually. That sounds pretty good.
Let's take a look
Yeah.
at it.
Also, I think that a lot of this is gonna be experimentally found. It's pretty complicated. So I think with a fan like that, it's beefy enough that we can do a large range of speeds. And so like, it's something we can find out experimentally, and we can test absorption rates as we go and stuff like that.
Can we vary the speed of the fan? Is there just like turn on and goes max?
I don't know yet. There's a couple things we need to
Oh.
know. We need to know about it.
If it's programmable, then it's most likely, like, if it can do the things of on and off, and like work with like an interface in that regard, I'm pretty sure like should have like speeds.
Yeah. What does it say down here? Does it show any variation even? Minimum, maximum? Is that what that means?
No, I think that's meters cubed per hour. I think that's what it's saying.
Yeah.
Whatever it is, the PA is Pascal, so that's obviously pressure. So there's different pressures, so that implies different flow rates. So it looks like it's adjustable.
Okay. Well, there's a couple different products that are listed here. So these are different products. So
Oh.
one line will have that. Let me just see what it says. Special shutter which protects it from overheating in case of sudden power cut. Grills. Factory medium alloy. All right, let me look at the second data sheet here. All right, this one here. Now, there's two different options. One is a bit more fancy than the other one, but the less fancy one, which you're looking at right here, has a lot to recommend it. It's our nice circle shape, and I believe it is, in terms of dimensions, let me see what the dimensions are. Open diameter. So yeah, they're good. What's 120? What's 120 mm? That's like 5 inches. Millimeters.
Oh, 120.
Yeah, it's like 4.7, 5 inches.
Okay.
Something like that.
So it's not exact, but it's better for it to be smaller than 7 inches than larger. But it does create, like, I think we'll probably, as we've been talking about with brackets, like there's going to be a series of brackets that we put in there to place things, both the monoliths and stuff, where we could have a bracket that is on the bottom. Let me go back to the image here. So if we look at this Ling's picture, this one here. So if we have like where the fan is there, even if it's not 7 inches interior diameter, then we could put some kind of a bracket on both sides or 4 of them, at different points within the thing that we screw in, and just sort of place the fan on top of that so it sits in there. I think that's probably there's no reason for us to be worried that this is smaller than the pipe, right? We feel like as engineers, we can figure out a way to get that thing in there where it'll stay, right?
Yes, sorry. Yeah, I mean, if the fan's too small, there's ways to go about that.
Okay.
Maybe get Lane to confirm that. But
Okay.
yes, I'm almost certain there's ways to get around that.
Yeah. And the other thing that's cool about this is that all of the motor and stuff are built into the axle. I do want to look at what the wiring situation looks like. How that actually works. I don't know if it shows it anywhere. We should call these guys up as well. I'll call these guys if you'll call the other ones and just find out. But it's circular. It can be super, super hot. And we also want to confirm that it can be, how did the electronics part work? And can we change the, the speeds of it and stuff?
Yep.
So I think that also requires a phone call. In terms of other stuff to buy, I think we're good to buy the cart. This is the one that we like. Pretty good price. You can put a nice, good stuff down there for mineralization. We can screw holes into it. It's aluminum. If we want to fix anything, we can put our balance of systems and the laptop on the top of it. We can easily, add some sort of bracket on the side. If we want to put the Epiphyte, the DAC unit hanging off the side, or if we want to position it on top, I think that's pretty uncontroversial. We can probably go ahead and order that. And we also, I guess, Will, we're good to order the PEI too, right? Oop, did I lose you guys?
No, I'm sorry. You asked Will about the PEI, right?
Yeah, Will, can we can I can go ahead.
He said he just said I'll be AFK for a second. That's right.
Okay, gotcha. All right.
What did you ask? I might be able to answer.
Just if we can go ahead and pull the trigger on ordering the sorbent.
Oh, like PEI?
Yeah.
I believe so. I think Will's confident about it. I think it's just about purifying the monoliths. He might want to do more tests. Maybe we should wait to ask him.
Okay. Well, I'll ask him and I'll turn that back to light green. Otherwise, we have we still are trying to find, we know what kind of monolith we want, but we just haven't been able to hook up with a supplier that we feel like we can trust and give us exactly what we want. So that'll require, we have a few calls out, like we mentioned. This is a whole other thing. I don't know if you guys thought at all more about the mineralization stuff. We'll sort of sidebar that for a second. But we are going to build that with this build, but there's a lot of decisions to make. Do we want to get like an acrylic cube? Do we want to get like an acrylic vacuum chamber? Do we want to get one of these kinds of vacuum chambers, with a pump? So that'll be kind of the sequestration team on Thursdays and Sundays can work that out. We're ready to do something. We'll go ahead and order. Okay. So let me just take a look at this fan too, as well. This is from the same supplier. It's just a little more complicated. Let's see what it tells us. It's bigger though. I think it's the same data sheets. All right. I'm going to call up and just kind of get a comparison and explain what our use case is and see if they have a recommendation for either one. And we're going to want to order one of those regardless for the heat distribution. So by ordering one, it doesn't, preclude the possibility of ordering another second big fan if we do feel like we need more air. So once I call these guys up, and if they make a recommendation between the one product or the other, I'll go ahead and order it. All right. So we're ordering the stovepipes today. That's going to come to my house, and as soon as it comes, I'll come drop it off either on Thursday or Sunday, so that you guys will at least have your hands on that.
Sounds good.
And I think that's pretty good in terms of stuff we really want to order right now. I don't think there was anything else. I think we're good to go. The other thing we want to look up is like the actuators, which we don't have listed here, but we will want to try to find like a universal actuator that will work with that. damper. So why don't we get the damper in hand and then be able to take a look at it and then search for the actuators from there. They're pretty expensive and we need 2 of them. So we'll want to get one obviously that works and that we can, automate, but we also want to be, conscious of cost as well. All right. Well, I guess that is kind of it on the ordering of parts. So I'll let you know when they tell me how long it's going to take to get here. It says on their website 3 to 5 days. So that means if I order it today, I'll probably have that in hand and maybe even dropped off to you guys by our next meeting. Cool. Any other questions? Any other stuff? We talked about a lot of stuff, Tom and Chaz, on Sunday. Can't remember. Oh, one of the things that we were looking at too was this. We have to figure this part out. The tube. We need to. We're thinking like 2 inches. Evan, the purpose of this is that just to recirculate air. But that introduces the whole problem of cutting a hole in the pipe. So we need to obviously think through what kind of tube do we want for that can be used with high heat, and that one that can easily with some form of sealant be securely connected at the top and the bottom so that it it doesn't leak. We need to leak proof the crap out of this thing. So I didn't know if anybody wanted to look at that. I was looking at one product for that that I think I have listed here. Where did I put that? Might be up here. Electric coils. Oh no, that wasn't it. Where the hell did I put that? Maybe I put it over here. Let me see here. Models, chimney components, electronics. I might have put it under the bomb. So again, this is going to be the final thing that we do. This first page, as you guys know, is just where we put things we're considering. But when we finalize and are certain that we want, oh, here it is. This is this ProFlex tube.
Chris, you're still sharing. You're still screen sharing. Link's
sorry.
drawing.
Yeah, let me get rid of that. Let me present. Sorry. Entire screen. Boom. This was the product that looked like it might work. It is high heat. It's flexible. It's 2 inches in diameter. It can get up to, oh shit, it can only get up to 90 C. I misread that. Let me see here. Clearance of combustibles for installations at exhaust temperatures of up to 230, 110. 110 is probably fine, right? I think that's what I was looking at.
I think that's a good number.
Okay. So I'm going to look in and see what the quote is for this, but it looks.
I'll also talk to the mass transfer team about looking into that as well.
Yeah, I'll transfer that from the bomb tab over to the other one and highlight it. If they want to just look at it, and you have a sense of what we're looking for here, it just has to be heat resistant, right diameter, flexible, not super expensive, and easy to potentially have some kind of a gasket or some kind of sealing thing we can put on it. So if you guys want to just look at that a little bit and see if you find any other product, and otherwise I'll call up these guys and ask them tell them what the use case is and see if they think that this will be good and what things cost. But this looks like a serviceable option for that. All right, cool. So we have at least a couple parts that we're definitely ordering, and probably another 2 or 3 that we'll know before we speak next. Let me stop sharing. All right, cool. Anything else that we want to talk about, guys, that kind of popped into mind based on our most recent discussions?
Well, Will's back, so I think he can answer your question about the PEI. You asked.
Oh yeah, we're good to go on that PEI, right? I can go ahead and order a liter of that, right? There's no reason not to.
Yeah, the same link that you put in the chat.
Yeah, exactly.
Yep, that's
okay.
Good.
So we're ordering the sorbent today. We're ordering the stove parts. The next 2 days, we'll have the calls around the heater and the fans. Hopefully that provides clarity. Once we get yeses on that, we'll order those hopefully before the end of the week. So most of the essential products will be then ordered. And again, I'm going to order them in my house and then bring them over to you guys. So you'll be able to get your hands on some stuff. Next week, we'll probably want to talk about this stuff, obviously, but also the sensors. You guys have the sensors that I brought over. You can look those up and look at the spec sheets. But we'll probably want to think not only about sensor physical placement, but also the software side of it, the programming that we'll want to update the last code that we created for it to work with this product. But I don't know if we have any CS people that want to join, like Caleb or whoever, but it would be good to get that going in parallel.
All right. Yeah.
All right. Let me see here. We have a couple questions here. Just going back to one, I think you already answered that from J3NX about the multiple cycles. The other thing too, Will, is I will respond to Kirsch and see if he's willing in the next couple weeks, once we get our monolith and the sorbent, if we can do a little workshop with him on screen, giving us the walkthrough. And we feel like the oven that you have in the lab gets really hot, so it's probably pretty good for this already, that we don't need to go beg somebody at a ceramics department for their oven. So.
Yeah.
All right. So that's kind of all I wanted to cover, unless anybody had any other cool things they wanted to talk about, or if Evan, you had any questions or ideas based on the fire hose that we just subjected you to. But otherwise, we can call it a day early. All right. Sounds
All
like
right.
we're good to go. All right, guys, enjoy class. I'll let you know when I get the boxes, send you some pictures of them on the Discord, and then we'll come up with a time and place to meet where I can hand them off to you.
Sounds good.
All right.
All right.
Thanks, Chris.
Awesome, guys. Catch you later. Bye.
All right. Bye, Chris.
See ya.
Thank you.